Good morning, everybody. Welcome to Workshop Wednesdays. My name is Megan. I'm the marketing manager here at Monolith Forensics. If you haven't been to Workshop Wednesdays before, basically what we do every 2 weeks, live at 10 a.m. Central, we do a webinar on a practical forensics topic. Usually our CEO and founder does topics. Sometimes we have guest presenters, but really the idea is just we want to kind of provide some free, interesting information related to digital forensics. Provide that for you guys. So, just a little housekeeping before we get started. If you have a question during the presentation and you'd like to come on and ask it live over microphone, we actually encourage that. We like to have multiple voices on these sessions. So if you have a question during the session, raise your hand and I'll give you permission to turn on your microphone and you can ask your question live. Or if you prefer, just drop it in the chat, and we'll be sure to get those questions answered for you. So with that, I'm going to hand things over to Matt and I'll come back for the Q&A.
Okay, great. Thanks, Megan. And thanks for everybody for joining. We've got a solid group today. I think we have about almost 100 people joining us today, which is great. So thanks everybody for joining us. We're going to hop into the presentation. Before I do, I'm going to say my little quick sales pitch. So if you don't know who I am, or if you haven't joined these before, my name is Matt Danner. I'm the CEO of Monolith Forensics. At Monolith, we have one commercial product that we sell. It's what we make our money from. It's a product called Monolith, which is a lab management system for digital forensics teams. So if you're working in digital forensics, whether you're in law enforcement, e-discovery, cybersecurity, digital forensics consulting, the private sector for litigation, if you need something like a lab management system or project management system for your digital forensics team, just head to our website, take a look. We have lots of information on the website about the product. We also have a YouTube channel where we've posted tons and tons of videos about both Monolith and also these types of webinars. So if you want to see our history of other webinars, you can go to the YouTube channel and watch our previous webinars. But yeah, if Monolith is something that you think you could use, just reach out to us. There's a contact form on the website. Just reach out and we'll be happy to schedule a demo, show you the software, tell you what it's all about, and get you a trial so you can play with it yourself. So, all right, cool. So thanks for joining. We do these webinars every 2 weeks. So if you like this, please come back and see us again in the next webinar. So today what we're going to talk about is I'm going to do a little bit of a case study on a phishing email we recently received. So a few weeks ago, our team was hit with phishing emails are pretty common nowadays, so companies get them all the time. But this one was particularly interesting, so I decided to do a little bit of our own forensics on it, just to kind of break it down, because I was curious to see what these attackers were doing. We didn't succumb to the attack. I think I got the phishing email like twice, and then one of my sales guys got it once, and we pretty much picked up on it right away. So we didn't fall for it, but I took it as an opportunity to kind of just do a little bit of forensics and a little bit of investigation into it, just to see what these attackers did, what their strategy was, how they implemented it, that sort of thing. And so what we're going to do is we're going to do a bit of a postmortem here. We're going to break down what this phishing attack was, how it worked, and just kind of show you guys, what these attackers were trying to do. So I'm going to share my screen, and I'm going to switch over to my my number one forensics tool, VS Code, which is a great little multi-tool. So if you guys have never used VS Code before, it's basically a programming editor. It's what we use to actually write code for Monolith and other projects, but it's also a really, really great, I find it to be a kind of a low-key sort of underutilized forensics tool. And I'm going to show you why here in a second through this presentation, because it just makes looking at data like this really easy and simple, and it just has a lot of built-in tools that make data examination kind of nice. So just get started. What you're seeing here, you should see my screen, and what you're seeing is the actual phishing email itself. I have anonymized it, so it's you can't tell who this came from, but basically what happened was one of our customers had their email account was compromised at some point, and the attackers used this person's email to launch an attack. It looks like it was a widespread attack where they sent this email to, not entirely sure how many, but to dozens, if not hundreds, of users in this person's email contacts list. And what it is just an email that came from this person, that came from their real email account. And it's a pretty simple one. And you can tell if you've been in this industry long enough, you can tell on its face it's pretty obviously a phishing email. It doesn't really require a genius to figure that out. It says, please attach the proposal file for you to review. For us, it's particularly interesting because we're a vendor, so we sell products to organizations like this all the time. So when we get an email that says something like, "Oh, here's that proposal that you need to review," that's not an uncommon email for us to get. Like, we get emails like this all the time. So it's not a crazily constructed email, but our team is smart enough. My sales team is smart enough to know, they recognize when they're expecting documentation. They know when they're expecting stuff from customers. So they're smart enough to know that when they get something like this from a customer they're not expecting, they generally know what to look for. They know what a suspicious email looks like. And in this case, they picked up on it and reported it to me right away. I also got the same email because we were in this person's contact list like 3 different ways. So I got the same email. So here's what it looks like. It's pretty simple. The subject line even says scanned from a Xerox multifunction printer. So it makes it look like they scanned a document to a printer and just emailed it directly to us. So, they're trying to play a little bit of a little bit of game there and try to, manipulate us into thinking this was some legit email because they just scanned it directly to us. But anyway, what happens is you click on this PDF link that's right here. And what it actually does is it takes you to their primary launch page, which looks like this. And you'll notice I opened this up, and don't try this at home. If you do this, be very careful about how you access these things and how you access these systems. But I open it in incognito mode. I know what I'm doing. I know what I'm looking for. So I'm not worried about compromising myself, and just be very careful about this stuff. And what they have here is they have their primary launch page. And this is here. The reason they do this is what they're doing is they're trying to get around email scanning systems. So if they just put a link in here directly to the bad phishing page, the page that has the actual, payload or malware on it, some email systems are smart enough to actually dig into the link, research it, and figure out, where is the actual, actually look at the page and the link and determine if there's anything fishy about it. So what they do is they do a multi-step hop where they take you to this initial page here, which is simple. It just says you have received new documents. Click this link. When you click this link to open the document, it then takes you to a fake SharePoint location. So right here, what you see is this is the next hop. So this is like one hop away from the actual email. So email scanning systems will not come to this link. And what you're seeing is just a fake SharePoint site. And if you look at the URL, you can see they've created this really long string URL. And the purpose behind that is to make the user think, oh, this is like one of those weird temporary URLs or something that they see all the time when they're downloading files. So it's made to look like it's just this complicated URL that you don't think twice about. You don't look at it too hard. But obviously, if you look closely at it, those of us in forensics can see this is a fairly strange URL, especially this workers.dev domain. It's a very strange URL. And we know this is not a SharePoint site, even though the rendered HTML is making it look like a SharePoint site. It's not a SharePoint site, right? Now, this is where it gets interesting. So in this attack, what you're seeing is they're getting a verification code of some kind. Now, what's interesting about this is if you access this page multiple times, you'll get a different verification code each time, because what's happening is the attackers are using a legitimate authentication process that's called device code authorization. It's one of the functions of the OAuth code process, or OAuth authentication process. It's one of the mechanisms baked into OAuth. And what that device code authorization flow is, it's basically an authentication process that's used for, basically devices, like physical devices or installed desktop applications that do not have traditional session management like a browser does. Okay, and the way that it works is the device that you're authenticating to will use some, an authentication-based code generation system where it creates a authentically secure code, which is what you're seeing on the screen. And the user then authenticates with their identity provider. And then that code is a part of the authentication flow that authorizes the device or application to use this user's authentication mechanism. In this case, what the attackers are doing is they're trying to get the user to provide them with authentication and authorization to their Microsoft 365 account. And I have a little chart here in a second that will show how this device code flow process works. But basically what's happening is the user gets to this point, they copy this code, they click the continue to Microsoft button, and that takes them to this location here, which this is a legitimate Microsoft authentication page. And you can see even in the URL, you see it has that OAuth2/device auth. And that is one of the endpoints that Microsoft uses for this device code flow authorization process. So the user will enter their code here, and when they click next, what Microsoft is going to do is going to walk the user through their authentication process. Now, what's interesting about this is this will then have the user log in their Microsoft account, which they may already be logged into it. And then it's going to likely, in most cases, it's going to have the user go through the MFA process on their Microsoft account. In some cases, it might not, depending on how their Microsoft tenant is managed and how it's set up. It may just go straight through if they're already authenticated. But most cases with device auth, it's going to have the user go through their MFA process. Now, the magic behind this is that once the user gets past this and authenticates through their username, password, and MFA, what happens through this device auth, what the results of this device code flow authorization is Microsoft will then return a refresh token and an access token related to the user's Microsoft 365 account. And since we are basically authorizing a device authentication to the attacker's system, the refresh token and access token get sent to the attacker's endpoint. So when the user completes this process, the attackers now have a refresh token and access token to your account, to the victim's Microsoft 365 account that they can then use with Microsoft's API, or they can use it for, they might have a custom application that they bake the refresh tokens into, and then they can access the account and do things with it. So, and the reason that's important is by doing this process, the whole point of the device auth code flow is that it's authenticating a device to your account. It's not authenticating a user. So what that means is that once the device has authentication, it doesn't require a user to log in or do these MFA, plugins or anything. Like once the device is authenticated, it has access. It can just now perpetually have access. That's what the refresh token is for. The access tokens may be short-lived. The access tokens may only live for anywhere from 5 minutes to 1 hour, usually. So the access tokens will expire, but the refresh token is a long-lived refresh token that can last for, that refresh token can be good for several days. And the way the process works is when the attackers are using the account to do nefarious things, they'll use the refresh token to constantly get new access tokens that are refreshed. And then in that process, they can also refresh the refresh token itself. So this is the whole point of this device code flow, is that you're giving a non-human system, a non-human device, access to the account so that it doesn't have to constantly enter a username and password or MFA. Because a user would have to do that because we want to make sure users are going through that authorization flow. But for a device like a television, a computer, a desktop client, a desktop application, it's not possible. The application just simply can't log in with the username and password every time. So it needs to have this consistent and persistent access. And that's what access tokens and refresh tokens are used for. What that means is if a user is compromised through this process, the only way to remove the compromise, to remediate it, is the user has to go into their account and basically disconnect all connected accounts. So when this process goes through, the user should be able to log into their Microsoft 365 account, and they will see whatever device was whatever simulated device or application or whatever that the attackers received code authentication for here. And then the user can go into their account and deauthorize it, basically. But until they do that, the attackers are going to have access to this account and they can do whatever they want with it. And that's how they basically get around this MFA problem where, they have, in order for them to access your Microsoft 365 account with MFA, they need to somehow bypass that MFA process, because even if they have the user's password, that's not good enough. They still need to have MFA authorization or verification. And the way they get around it is with attacks like this, where they have the user go through the authentication, they do the MFA, and what they get in return is a refresh token and access token that does not require consistent MFA authentication flow. So that's why these attacks are powerful. This is how a lot of these attacks occur and how they're bypassing MFA within organizations is they're basically just using the users against them and using this device authorization flow. So a couple more screenshots we have here. This is a screenshot of the developer tools that I grabbed, specifically this init endpoint. So if you look at this, you can see the request URL here is whenever the page is initially loaded, the app or the phishing page is making this API call to this workers.dev/API/session/init. And what this is this is the endpoint that the attackers call to initiate the device authorization code flow. They have the Microsoft SDK running on their backend attack server that they get this endpoint from, and they start that device code authorization flow where it returns from the server that code that we saw on the screen earlier, this mock page. That's where this code comes from. It's coming from the attacker's backend, going to the user, and then the user uses this to complete the device code authorization flow. Okay? So to show you a diagram of what this looks like, because this is a fairly complicated, the device auth code verification and OAuth is a fairly complex set of steps. So this is something I highly encourage you to go do some research on your own to figure out how this works. It's fairly complicated, but I put this chart together to kind of try to illustrate how this works. So what's happening is the attacker's system uses the Microsoft SDK, OAuth SDK, to request a device code from Microsoft. Microsoft returns this device code. The code gets then passed to the phishing page to the user. And that's where we see this verification code, right? That's what we see here. That's what we see here in this picture here. This is the code that the attacker server is returning from Microsoft. Okay. The user then enters this code into the Microsoft authentication flow, which requires them to authenticate as a user because they're effectively saying, hey, Microsoft, there's a device that you've associated this code with, and I want to give that device authorization to my account. Okay? So that's what's happening here. The user enters this code, which Microsoft knows is identifying a specific authentication session for a device or an application. And then the user logs in to tie their authentication to this code and that device. Once the user logs in and authorizes their account, the attacker, the session is now created, and Microsoft then sends back refresh tokens and access tokens to the attacker's server. Okay? Now the attacker can store and save those tokens and then use them to do whatever they want, with the account. The last step here, this isn't the full code. These last two steps here are really just the user gets redirected to like a real SharePoint screen, saying, hey, thanks for doing this or whatever. And so the user just thinks they don't see the document. They may not understand what happens. They just see like a SharePoint site. And then at the end here, we have the attacker now holds tokens to the actual account. And then from here, they can do things with the account without any additional authorization, without any MFA verification, nothing. They can have scripts or applications that they've built that allows them to extract or review data or do whatever they want, or even send additional emails. So that's probably how this initial email may have been compromised through a similar process like this, and then you just keep repeating that process until they get access to data or something that they want. Okay. So that's how this phishing attack worked. Now let's break down like some of the mechanics and some of the details of how they got this to work. So one of the things that I did was when we got to this phishing page, I wanted to pull it up and actually see what the page looked like. And what's really interesting is when I was looking at specifically the phishing page, this page here, or this mock page here, not that one, but this mock page, I wanted to pull up DevTools and actually examine the page to see what it looked like. And one of the things that was interesting to me is, I'll pull these up side by side so you can see what they look like. So if you look at this page here, or not this page, sorry, this is the wrong one, SharePoint mock page. If we look at this page here, the HTML that loaded this page looks like this. Okay, it's literally nothing but a script tag. The HTML just has one div with an ID of R, and that's it. And then it just has a big script block, which is really interesting. Now, I'll admit it's been a while since I've done any kind of incident response casework. It's been a few years, so maybe this is a standard process now. But I've never seen this kind of obfuscation before. And so when I was looking at DevTools, I saw that all this was a script body, and then it just had this script here. And I can take the word wrap off so you can see a little bit better what this looks like. You just got this block of JavaScript here. And I was like, well, how the hell did we get to a rendered page, fake SharePoint page that looks like this from this JavaScript that looks like this? And so I decided to kind of break this stuff down. And if we look, if we just extract this JavaScript, we can put this into a script file like I did here and get a little bit clearer view from use VS Code's syntax highlighting capabilities to try to actually break this thing down. So if we walk through this code for a second, let's see if we can figure out what's actually happening. So we have at the top of the stack here, we have 3 variables that hold some strings that are clearly, this is obviously base 64 encoded data, okay, of some kind. Like, okay, that's interesting, especially this. This is a really, really long string of data, base 64 data, which is interesting. And then we see a function here that looks like it's doing some kind of bytecode conversion, which is interesting. And then we get some interesting lines of code here that are calling the web-based crypto API. So if you're familiar with the browser and JavaScript in the browser, most modern day browsers now have a crypto module. And what this is just an encryption module that's built directly into browsers where you can do all kinds of stuff. You can calculate hashes with it. You can encrypt and decrypt data sets using different algorithms. And here what we see this crypto.solo.import key function being invoked and being stored as variable k. So someone is setting up an encryption key basically for this. Or they're setting up an encryption context so that they can encrypt or decrypt data using certain variables. And then down here, we get the crypto.subtle.decrypt. So now we know somebody's decrypting something here. And they're using the AES GCM algorithms. And we can see the different parameters being passed to this decryption function. And then down here, we can see document.open, document.write, and document.close. And so what these are in JavaScript parlance, these are basically functions where we are writing directly to what's called the DOM, the document object model in the browser. So we're getting some kind of data and we're manually loading the browser with content. Most of the time, the way browsers work is HTML data gets served from a server, the browser receives it in an HTTP call, and then the browser renders it in the browser automatically. That's just how browsers work. Here, we see here's the HTML getting rendered initially, right? It's just basically a blank container. And then once this loads, the way that the browser works, it'll load this div, and then it will run this script. And the result of this script is that it's doing some stuff, and then eventually it's writing some data directly to the document body. So we got to now figure out what that is. And so down here, we can see some more document related stuff where we see script element being created. And then we're seeing another base 64 string with some being stored into this script content. So you can see the variable here is being initialized as a script element. And then we're saying, hey, for the script element, set the text content to this base 64 data. And then we're going to append this script element to the document body. Okay. Now we're getting some base 60. It looks like we're getting some base 64 data. We're decrypting it, and then we're loading it into the DOM. And then we have clearly some kind of additional JavaScript that's obfuscating base 64 that's also getting added to that HTML page as well. So now our job is to now figure out, okay, all right, cool. It looks like this is an obfuscation. So what this is an obfuscation technique by the attackers. And the reason they're doing this is they can dynamically load the bad page because let's say that this goes to a company or organization that has really strong, heavy network firewalls that basically look at or view all the web traffic that the users are going to. Well, that network traffic that's being examined, because of the way this is dynamic, the page is being dynamically loaded in this way, it doesn't have most, to my knowledge, systems, these sort of firewall systems don't have the ability to read this code and understand how the page is using this code to render itself. So this is either going to bypass filters, or it will only get caught if the filters are set to look for certain invocations of JavaScript. So things like, hey, for some reason, this page is loading the crypto modules, so we want to be extra careful about that. Or, there's certain signatures that a firewall system is looking for in that page to prevent the user from loading it. But if it doesn't have some very specific signatures that it's looking for, it's not going to be able to read whatever this content is being loaded into the document as it's passing through their network, because this doesn't happen until it's already in the user's browser. So for a network firewall monitoring system to catch this, it has to catch it on its way to the user, not after it's already been loaded. And so that's the purpose behind this, is they're just trying to obfuscate, the bad stuff that this page is doing. So let's see if we can break this down. What I've done is I took this and I used CyberChef to try to decrypt this and break it down. And just to save some time, I already put the CyberChef recipe together and I've got it here. So we're going to pop this into, going to copy this thing and we're going to pop it into CyberChef so I can show you guys what that looks like in case you've never done a CyberChef recipe before. So I'm going to load recipe. So I've got CyberChef pulled up. If you haven't used CyberChef before, it's just basically a decryption, encryption. It's a data manipulation library that it's very useful in instant response and forensics, where it just has all of these different data manipulation systems just preloaded, so you can just use it whenever you want. And here, I'm going to just click load recipe. And right here in this block, I can just paste that JavaScript and load it in. And what I get is this nice clean recipe where we can go back to our script, which you're not going to see this, but I'm just going to copy that big long string of base 64 text. I'm going to paste it in. So bear with me for a second here. I'm going to paste this into our input. And so what we get is pasted in that big long base 64 string. And then what we get down here is our rendered HTML content. So it's hard to see here because it's not prettified, but I wonder if there's an HTML format. There isn't, but basically we can see we've now converted and decrypted this base 64 code into browser-based HTML content that will be rendered. And just to walk through the sequence here to let you understand, we've pasted in base 64. So the first thing we're going to do is we're going to do a base 64 conversion to convert this base 64 into bytes. And then we're going to do a hex conversion to convert it to hex. And then because of the way that AES encryption, their version of AES encryption works, the part of the encryption code is actually contained in the last 32 bytes of the payload itself. So this find and replace is basically just extracting and removing those last 32 bytes from the actual input so that it's not a part of the decryption process. And then down here, we get to the actual AES decryption process, where this is where we have to extract these values from the JavaScripts, because if we go back and we take a look at our JavaScript again, we can see in this script, remember, we have these variables at the top here. We have A, which is our big long base 64 string. So this is obviously the page content. And then we have these two other variables here. We have B and C, which are shorter base 64 values. And what these are the other encryption parameters that are used by the AES encryption scheme that they're using. And you can see here in the decryption process, we have the IV value, which is F of B, right? So this is our IV value. And this function here that's being called is just a simple base 64 conversion function. So it's just loading the byte array of that base 64 IV value. And then we have K here, which K is the sort of key that we created using, again, F of C. So C is our actual decryption key that we're loading into our crypto module. And so when we're decrypting, we're then loading that key context into the crypto module for decryption. And then we have finally this F of A. And this is the actual payload that's going to be decrypted. So that's the arguments you're seeing here in the decryption. So we have everything in the script. We have everything we need to plug into that AES decryption process. And you can see here we have the key value starts with H. Oh, sorry. Let me switch back over to CyberChef. Hang on. So like what we have here, we have our decryption key here. We have our IV value. We have the mode as GCM, which we saw in the script as identified. Our input is going to be hex because we did our hex to decimal conversion up here earlier in the recipe. We're going to output it to raw. That's what we want. So we could also do it to hex, but if we do it to hex, we're just going to get this output, which isn't useful to us. That's just bytecode. Basically, we want to see the raw output. It's basically ASCII. And then we also have the GCM tag, which this is the 32 bytes that was extracted from the payload. So there's just an additional salt basically to say, okay, you need to make sure that what you're decrypting actually matches the payload that you're trying to decrypt. And this is part of that process where we just extract this from the last 32 bytes of the payload. And then what we get as a result is we get this decrypted page. Okay. So if you've never used CyberChef before, this is an excellent demonstration of how to use it. The other secret sauce to this is, I would say, is if you get something like this, like a script like this, and you're trying to quickly decode it, this is a great use for AI. AI is really good at this stuff. You could literally paste this base64 code into Claude, say, hey, Claude, this is an encrypted, here's the script related to this payload. Can you create a CyberChef recipe for me to decrypt it? And it will most likely get it on the first try. So this is another great use case for AI, as we often talk about in these demonstrations. So now that we have this, let's take a look at this actual HTML data, because I already have it decrypted and pasted into VS Code. Now we have our decrypted page here. So this is what the actual page looks like after it's been decrypted and rendered from that base64 code. So we have our typical header stuff for the page. We have our styling, a style element here that has all of our CSS. We collapse that, so we don't care about it. And then as we go through, we can see all these different rendered objects. We can see SharePoint file share. And we can go through and look at all these different things that map to our mock page here. So SharePoint file share, and we can find all these different elements inside this HTML just to confirm for ourselves that this is in fact the code, the HTML that's being used to render this page, right? So access shared file, we can see that's right here. Access shared file, that's an H1 element. We can see this also, this message. So basically all this is here just to show us like, okay, yeah, this is more, this is the page that's loading. Now, we're not done yet, right? Because as we scroll down, we can see, okay, here's all the HTML content, all the rendered UI elements, but now we have another script tag down here with more JavaScript, right? So now we have some more JavaScript to review. And luckily, I've already extracted this into another file called decryptedscript.js. And so now we have some fun going through some JavaScript data here. Now, if you're not familiar with JavaScript, if you're not a strong programmer and you have a hard time going through stuff like this, guess what? Throw the script into Claude or your AI of choice and just have it do some analysis for you. Say, hey, can you look at this code? I extracted it from a phishing website. Can you please tell me what's going on with this code? Help me understand what's happening here. And like here, I could even just pull up Claude right here in VS Code. And I can literally, you can see here, it's already, because I've opened this file, it's already got the context of the file. I can literally just ask it, hey, tell me what's going on in this file. And it will literally look at the file, analyze it, and tell you exactly what's going on with it. So if you're not a strong programmer, you can use AI this way to just basically leverage your skills, to basically give you a skill set you may not have or be very strong in right now. But if we walk through some of this code, we're going to see a few things. We're going to see, okay, here's that API call that's being made. This is initializing that auth code flow with Microsoft. The other thing I forgot to mention earlier is this X anti-bot token. I forgot to mention this, but I'll show it to you right here in this screenshot. So one of the other techniques they use to try to protect against testing and investigators looking into things, the init endpoint that starts that Microsoft device code flow, is they added a custom header called X antibot token. And it's funny that they literally call it antibot token, but what this is just an extra little piece of information where their backend servers will reject any requests that don't have this specific token attached to it. So if you are doing some reverse engineering, if you're testing these attack servers, things like that, you have to pay attention to stuff like this because these attackers are smart enough to use these little random techniques to try to make it just a little bit harder for us to investigate what's going on with these phishing attacks and these attack servers and things like that. So this is an interesting one. Again, this is not something I've seen before. I'm sure this is common now, but it's relatively new to me. But it's good to note that they're doing little things like this. So it's also important why us as forensic examiners and incident responders and things, we need to be up to speed on things like this, like understanding how browsers and servers work and how request headers work and how HTTP works. So we understand when we see stuff like this, we can sort of reverse engineer what it means and what these bad guys are doing. So we get back, we go through our script again. Here in this part of the code, it's making that init call. It's getting a result back, storing it as JSON. And you can see here, this is where they're actually getting that code that they got from Microsoft and displaying it into the browser right here. They're grabbing that UC element here and they're pasting that user code value. Okay. As we get down, so that's function SF. And they've obfuscated this code even more by uglifying it. So they're using non-semantic function names and variable names. This is pretty common as well. So just be aware of that. So we have to work a little extra harder to go through this code ourselves. Again, here it's making a session status call. This is trying to figure out if the user has completed their session authentication process or not. We have one here as well that is, it's setting up another function, which I don't remember what this one is, but it's doing some kind of, looks like this is handling the copy process when the user copies the actual code, the device code. Similar here with this function. And looks like it's hiding some stuff here in the browser, which may not be that important. Now that's the code that's loaded directly in here. Now, if you remember back to our initial review process, remember we had this block of code here where they're dynamically creating a script element and they're loading some obfuscated base64 code into it and then appending it to the body. And so what I've done was I've grabbed this base64 and decoded it. And that's what this commented section is here. And this is really interesting because what this code actually does, this is their obfuscation code. So this is where they're writing some JavaScript to try to make it harder for us to do our analysis. And a couple of things that they're doing, and I added some comments to this to explain each part of the code. But what they're doing is like right here, they've added an event listener that prevents the context menu from coming up. The context menu is when you have a browser open and you right click, you get this context menu. Then that's the menu that shows you things like, hey, open this page in a new tab, open this page in incognito mode, open DevTools, all that stuff. They've just turned that off. It doesn't prevent you from doing anything. It just makes it a little bit harder for you to access the additional browser functionality that would exist inside of that right click menu. Okay. The other thing is they're intercepting and swallowing keyboard shortcuts that open DevTools in the browser. So they've built this stuff in to basically say, hey, turn off all the shortcuts. So again, it's just a little bit harder for us to pull up the browser DevTools to examine this page, examine what's going on in the background. And they're just intercepting and killing these hotkey commands. Now, this one is super devious. This one was really interesting. This is the one I first ran into when I was trying to debug the page to figure out what they were doing. And they basically created a DevTools kill loop. And what this does is it basically runs a loop. So set interval in JavaScript is basically just a loop, an iteration loop, where it's going to run every 1 second. This is in milliseconds. So every second, it's going to run this little loop. And what it's checking for is it's using this performance calculation, which is really interesting. So it's basically starting a timer, like, hey, start a timer, and then run the debugger. And what this debugger command does is if DevTools is open, this will start a debugger in DevTools, which is basically, if you've ever written code, this is like a debugger inside your development environment, except this is running in DevTools. And it basically pauses the page while the debugger is open. Now, if DevTools is closed, this debugger just doesn't do it. Making this call literally does nothing. It's just a null and inert function call. or an invocation, so it does nothing. And so what they're doing in this little bit of code here is they're testing, hey, I want you to calculate how much time has passed since I started timing this function and right now. So just between these two lines of code, it's saying how much time has passed. Because if the debugger is open, if the DevTools window is open and the debugger actually does something, it's going to take longer than 100 milliseconds for it to reach this line of code. So what it's basically saying is that, hey, if the performance calculation is greater than 100 milliseconds, I want you to kill the document body, basically blank out the page, the DOM page, just by setting inner HTML on the body document to empty quotes. And then I want you to reload the entire page. And so what this does is if you have the DevTools open while you're looking at this phishing page, which is this page right here, if you open up DevTools here, this little bit of code is basically going to perpetually open up the debugger and pause and kill the entire page. And you can't do anything about it. Like you can click the play button on the debugger again to get it rolling again, but as soon as it does that, it's going to go right back through this loop and it's going to blank out the page. So what this means, this bit of code means that if you have the DevTools open and you're trying to look at what's going on in the page, this little line of code is going to just make it impossible for you to look at what's going on. So at this point, in order to deal with this, you either have to neutralize this line of code in the browser somehow, or basically extract the page directly like I did. And then we could do things like I could then neutralize this code and run it in a browser and do all that stuff. But basically, it makes it to where you're going to have to use a different technique to download this data and actually look at it. And then lastly, this last bit of code here, again, this is just some extra stuff where they're basically just killing all of the console functions so that none of the console log output will work. And you can see console.log, console.warn, all these different console functions are being turned off and replaced with it. And this is an interesting JavaScript thing. Some engineers will say this is a complaint to JavaScript, but basically you can just reinitialize any function you want to anything, right? So here they're creating a function that does nothing. It's just an empty function, and they're resetting all the console functions to a null function, basically, so nothing gets output to the console. And so just to demonstrate quickly, to those of you that aren't familiar with this process and what the DevTools or the debugger is, I'll quickly kind of show you here in CyberChef. So right here, if I right-click here, you can see this browser context menu. And this is the context menu that they've killed in their obfuscation script. And I can click Inspect. And when I click Inspect, it opens up this DevTools window in Chrome. And I can do things like I can look, this Elements tab shows me all the elements that are being rendered in the actual page. I can look at the console to see, error logging or any kind of logging that the page is outputting. I can also check the network tab, and this is where I can watch network traffic that's actually happening with the page. I can look at sources to see, okay, what is the code and the content being loaded from the server for this application. I can check performance stats. I can even go into application and I can look at things like, okay, what's being stored in local storage, right? I can see that stuff. I can see session information. I can see cookies, all this stuff. But most importantly, the important part is I want to inspect this elements and see what's going on the page. I want to look at this application tab and the sources tab to see what kind of data is being loaded. But with that obfuscation technique where they are running that loop to test if DevTools is open and then clear out the page, it means as soon as you open this elements page becomes nothing. Like the entire content gets cleared because that's what that script does. So it's very, very interesting. So just to recap, to walk through what these guys are doing. And what was really interesting to me was just the level of obfuscation they were going through, right? So we start with, we've got this page that's being loaded. Well, first we have that jump where they have the landing page that then jumps the user to the actual bad page. So that's done to get around network scanning detection from email. So that's helping with email scanning systems that are going to and executing links to make sure the links don't have anything bad. And then it goes to this page. And then in order to bypass networking filters that are examining network traffic as users are going to different locations in their browser, they then use this obfuscation technique of baking the HTML rendered code into this base 64 block that is then encrypted. And even though the encryption is in plain sight here, what they're banking on is that these network scanning tools are not actually capable of decrypting the payload and actually loading it as HTML to see what it's doing. So this is another obfuscation technique, not only to bypass network filters, but also to make it a little bit harder for us as analysts to figure out what's going on here. So now we have to go through, grab this payload, figure out the decryption, put together, decrypt the content, and then actually look at it. And that's how we get to this decrypted page, which is the actual malicious fake SharePoint site. And then on top of that, they've even added some additional obfuscation, which is all these different techniques to make it harder for us to analyze the actual page to figure out what's going on with it, right? Now, what's interesting about this to me is it's been a few years since I've done any significant incident response for cybersecurity work, so maybe this is the standard now. Maybe this is pretty normal. If anybody has any comments on it, feel free to speak up and tell us if this is pretty common, what you're seeing nowadays. But in my opinion, I feel like this could be a sign of how attackers are using AI, where usually when I was doing a lot of cybersecurity work, I tend to find that attackers were pretty lazy with stuff like this. They only added enough obfuscation to be surface level difficult, but this is like multiple levels of obfuscation that we're seeing in this attack. And I get the feeling that these are kind of clever. This is, like all of these different obfuscation pieces here in JavaScript, these are very clever, different levels of obfuscation they've implemented. And I have to imagine this reminds me of how we use AI when we're writing code here, that the AI can be fairly clever at stuff like this. So my gut instinct is telling me that attackers are using AI to help them understand better methods and more clever methods of obfuscation, and probably using it for other types of assistance with their different attacks. So it's just something to keep in mind, where it's very possible that you're going to see more attacks that are less lazy because of AI, because AI is just giving them better advice on different ways to obfuscate things. So it's just something to keep an eye out for and look for. But anyway, I'll wrap up my analysis there. But I thought this was a really interesting, phishing attack to show. Especially as soon as I saw all these obfuscation techniques, I thought, oh wow, this is a really great thing to demonstrate to other folks to see what's the level of obfuscation that's going on here, and then also demonstrating this device code authentication flow that they were using to get access to M365 accounts and bypass MFA. So if you've ever had cases where you just couldn't figure out how a user's account got compromised, considering they have strong passwords and multi-factor authentication, well, this is how it's happening. They're using this OAuth-based device code flow authorization. So definitely look into that, learn how it works. It's a very common authentication flow that's used by desktop applications. So if you've ever used a desktop application where you've authenticated, where it opens a browser and then navigates back to the desktop client, this device code auth is basically what they're using to do that, to get refresh and access tokens for the application. So I'll pause there and see if anybody has any comments or questions or anything they'd like to contribute. Looks like we've got quite a few things. Megan, do you want to give me some help with that?
Yes. So we do have some questions in the chat, and I do see a hand raised. Let's go ahead and take care of the hand raise first. So I apologize. I am probably not going to pronounce your name right. Nkululeko. Boy, I'm really sorry. I'm going to give you permission to use your microphone, and then you can ask your question or tell us your comment, and then we'll get to the questions in the chat. You'll probably have to unmute also once you have your mic configured. Maybe.
He may have raised his hand by mistake.
Okay, well, we will come back to you if that is the case. Let me disable talking and we'll get to the questions in the chat instead. So the first question we had in the chat was from Lori, and she was wondering if this had anything to do with Anthropic.
If it had anything to do with Anthropic? I don't think so. I don't believe this had anything to do with any particular AI provider like OpenAI or Anthropic. I think honestly, this is a pretty standard phishing email setup. I think from my perspective, the only thing I thought was interesting was just some of the cleverness of the obfuscation. That's all. And it just kind of hints to me that uh, folks that are putting these types of attacks together, they're leveraging AI just to give them a little bit more cleverness to their obfuscation techniques is kind of how I look at it. Because I just don't feel like in the past when I worked this sort of stuff, I didn't feel like they were this clever or this thorough in their obfuscation. They'd have like one or two obfuscation methods, but that was it. Here, you've got multiple levels of obfuscation and even multiple methods of obfuscation within each level. So to me, that just screams like they used AI to help them research different ways of doing this and just implemented it as a part of their attack. I could be wrong there. Maybe this is perfectly standard phishing attack material now, and I'm just not used to seeing it. But that's how it looks to me based on all the AI development that we do here at Monolith.
All right, cool. The next question we had from Daniel, he was wondering if we were able to obtain any identifiers for the attackers.
Nope, I wasn't. The only thing I didn't dig too deep into the actual tracing of where everything was. We could have done some more investigation into these endpoints to figure out exactly okay where they registered, where they pointed. We also have things like the DevTools screen where we could have looked up the you know, IP resolution of where these domains were pointed and actually resolved like, okay, are they running this from servers in the US? Is this pointing to something in foreign country? I just didn't go that deep, but that's absolutely what you would normally do in a real investigation like this. It was mostly me just doing this out of curiosity and I kind of stopped at the reverse engineering point, but that's a pretty common thing that you would do is resolve some of these URLs and see if you can figure out where they're coming from.
All right, we got a couple more questions coming in the chat. From Micah, what specific log artifacts or telemetry in Entra ID, Azure AD, Azure
Yeah,
AD should
yeah.
we look at?
Yeah, I think honestly, the biggest sign here is going to be the fact that the OAuth based device code flow authentication is being used. So that's probably the biggest signature, which it is a common process, but you have to think about your organization and how many of your authorized applications even require this kind of authentication. So if you know that like, okay, we don't require this, you could simply just disable. I'm pretty sure in Microsoft Entra, you can disable this code flow authentication and then make it to where if somebody needs this type of auth on an application, you make it on a request by request basis, or do it under the context that, okay, the engineering team needs this for a tool that they use or something, and then just approve it for a certain subset of people. But the vast majority, if you're in a large organization, the vast majority of your users do not need this type of authorization code flow to be enabled. So either turn it off or have some kind of detection mechanism where you're looking for it. I did have AI do some analysis on it to kind of inform me on what are some possible remediation steps to prevent. Um, yeah, audit for illicit OAuth grants and remove any unrecognized enterprise app consents. So yeah, another thing you can do too is you can just have some kind of audit that runs does a review of all the different auth grants that have occurred in the past with users, and then just look for anything that looks weird. So the other thing that's interesting is it would be interesting to see what the attacker's application called itself in the user's account. So after the user completes this process, there's now going to be a registered, authorized device or account listed in their Microsoft 365 account. So it would be interesting to see what name they provided themselves for that. And that could be another signature you could look for any weird or unknown device or account registrations under this code flow authorization. Um, but yeah, that's pretty much those are the two that I can think of right now. I'm sure some other folks in here that are more experienced than me might have some better remediation or detection steps, but those are the ones I could think of right now.
All right, we also had a question come in from Derek. Could little snitch be of use when seeing where the URL is sourcing from? Not
I
sure.
don't know. I'm not familiar with Little Snitch, Derek. I'm honestly not sure. That's something. If folks on here hear this, is Derek is referencing something called Little Snitch, so you can investigate that, see if it's something that would help in a situation like this.
All right, it looks we have one more question from Keyshawn. He's wondering, how do we find if logs are not available, the O365 retention policy? Um, if the
Company to
it's it,
company.
Yeah, if the incident is a device
Yeah.
is identified a couple of months after, is there a way to filter for logs at the beginning stage?
Yeah, so it's a good question. I mean, it's pretty broad. Depends on the investigation and how it has started and unfolded. Obviously, if you don't have logs available anymore, what you still might have is if the user has authenticated, by the time you're investigating, if the user's account is still authenticated, you could literally just look at the different accounts and devices that are authorized on their account. But regardless of the log retention, you would still have those token grants that exist in the account associated with this attacker's server, device, or application that they registered. That's one way. The other way too is if you know what user this is associated with, you can do traditional forensics on their actual work machine too. So you're going to see things like the browser history, for example. You're going to see them in browser going to these weird URLs. So you can probably detect that pretty quickly just through browser history. You will also see in their email account itself, the logs may not be there, but the phishing email may still be there. So you can actually look for the actual email itself to see if that surfaces what the user may have conducted. Now, the problem with that is um, just because the user went to that link doesn't mean they actually authenticated. So you have to actually look at the whole of their browser history to see if they actually went through the authentication flow. And and users may be getting multiple phishing attempts throughout the year. So just because you find a phishing email doesn't mean that was the email that was responsible for a particular compromise. So there's a lot of chain of evidence there you have to go through to basically link everything together and confirm that, yeah, this phishing email was what was responsible for this particular compromise.
All right, cool. Looks like we had one last question come in, and then I think we're done for questions. If a user falls for this lure, what is the exact playbook or best step to sever the attacker's access?
Yeah, so basically you have to, because of this style attack, what the attacker has is they have refresh tokens and access tokens. So what you have to do is go into the account and effectively revoke those tokens because Microsoft stores references to those tokens. That's how they know they're authenticated. And you basically have to go in and, the user changing their password or resetting their MFA doesn't solve this problem. You have to literally go into the account and deauthorize and revoke any device tokens or application tokens that have been issued. Ideally, it should be easy to tell which one is the compromised token, but it's just best to just clear all the tokens, completely deauthorize everything connected to the account, reset the password, reset MFA, and then basically just continue monitoring the account for any additional weird access or any additional device authorizations and token issuance. And if you look, it should, and this can happen in Google too, by the way. We're doing Microsoft here, but this can also happen with Google Workspace. And in Google Workspace, and I believe in Microsoft, there's some pretty clear logs that show token grants and token authorization to different applications and devices. So that's what you want to look for. But basically, you just have to go in and clear anything that account may have authorized to, or anything the account may have been connected to in terms of third party or external applications or devices, and just remove all of it. Because that's the only way to know for sure that the attackers no longer have access to the account. Notice the URL for SharePoint, the value of 2000. Let's see. I'm not sure what you're referencing there. I don't see two. I'm looking through these screenshots. I don't see 2000 anywhere. Oh, it's on the script from CyberChef. Okay, hang on. Let me take a look. Was that in the HTML content or the JavaScript content? Down near the end. Let's see. Near Java when resetting. Okay. There's a 1000, and that's the loop. So that's like the interval. So I don't know if you saw 2000, but it's actually 1000, and that's the interval loop. So that's just 1000 milliseconds. So that loop to kill the page when DevTools is open, it runs every second or every 1000 milliseconds.
All right, awesome. Thanks for all these great questions, everybody. We are at time, so we'll go ahead and wrap things up. Thank you guys for attending today. Thank you, Matt, for sharing this presentation with us. And we hope to see you guys next week, or not next week, in 2 weeks at the next Workshop Wednesday. And hope you guys have a great couple of weeks in the meantime. Thanks for coming.
All right. Thanks, everybody. Bye.